Okay, so this lesson's about abstraction. Abstraction is removed from the AP test. Many teachers will still teach it even though it's removed on the AP test, because many people who are taking computer science courses in high school, like AP CSA, they will probably plan to go further into that and probably get a degree in college or something like that. So that's why a lot of the teachers, they still like to go ahead and they just like to teach abstraction, even though it's removed from the AP test. Since a lot of teachers like to teach abstraction in their AP CSA curriculum, I teach abstraction along with that too, but it's just, I feel like it's just helpful to know. However, if you're just studying for the AP test, you're not interested in delving into computer science or getting a degree in it in college, then just hop off this video. It's not going to help you. It's not going to help you get a 5 on the AP test. So yeah, that's really it. Okay, so let's go over our four core OOP concepts. Inheritance. Check. Inheritance is just when a class extends another class, or when a class inherits another class. We just use the extends keyword to just show that a child class is inheriting information from a subclass, or a parent class. Sorry about that. Okay, so that's Unit 9. Unit 9 is inheritance. Next is polymorphism. Polymorphism is checked. It's just when an object undergoes many forms, multiple classes are related to each other through inheritance. Part of a sub-lesson in Unit 9, inheritance. Finally, we got abstraction. We're covering abstraction in this video. Abstraction is no longer the AP test, so you don't have to worry about it. And then encapsulation is Unit 5, and that will be coming up next. Encapsulation is just when you sugarcoat a variable or an attribute, and then you try to access that, so you're going to make the program print it using getters and setters. It's a little interesting, but it's kind of a little difficult to kind of get the hang of it. But you'll slowly learn about it when you learn about accessors and mutuators. Those are the terms College Board likes to call it, but accessors just mean getters, and mutuators just mean setters. So you're going to hear them be used interchangeably. I just like to call them getters and setters, but they call them accessors and mutuators. They just mean the same thing. But encapsulation will be soon, and I am not going to cover that in this video. This video is about abstraction. Once again, abstraction is no longer on the AP test. Hop off if you're just here to study. If you're here to learn more about the computer science, if you're here to learn more about Java, stay tuned. Otherwise, if you're just here to study for the AP test, hop off, because this won't be on there. You won't be tested on this. Okay, so abstraction. What is abstraction? Abstraction is just hiding unnecessary details from a user. That's it. Abstraction is just hiding unnecessary details from a user. Abstraction can be achieved in 2 ways. You can do one way through interfaces, and another way through abstract classes and methods. Okay, let's go ahead and define the 2. We're going with the first topic, so we're going to do this first, and we're going to cover this second. So, abstract class. So, a class that is prevented or prohibited from creating objects. Then, we have an abstract method. I feel like it's always helpful to get some terms down before I start giving hands-on demos of them. So, it's a little hard for me to write exactly in line. You're gonna see my writing shift a little bit down to the right. That's just because of the way how I'm writing, but I hope it's still legible. I do write really small, and teachers do complain about it in school. A method that is completely empty. But I feel like if you're on the AP exam, you're doing your FRQ, you're writing pretty teeny tiny because it's good. If you have like really large handwriting, you're trying to do an FRQ on the AP test, yeah, you're not gonna have room. So it's kind of helpful I write small, but it's also gonna be difficult to read the teeny tiny stuff. Okay, so a method that is it's not completely empty. I'm gonna reword this. A method that has no body. And then after that, I'm gonna say must be in good. So I should just give a little space in there. There we go. So 2 words that we have defined. An abstract class, a class that is prevented or prohibited from creating objects. By the way, an abstract class and an abstract method in Java are defined using the abstract modifier. I've talked about the abstract modifier. That's just what it does. It makes a class abstract, it makes a method abstract when you put it in front of it. So defined in Java. Oh, my handwriting. Oh my god, I'm getting so much ink on my hands. Videos after videos of information. Good prep for the AP test. Got to score a 5 on that. Okay, we're done. Define through the abstract modifier. So, an abstract method is just a method that has no body. So, when I define a method through a signature, I'm going to say public void once you make your method declaration, you usually have 2 curly braces. And inside is your body. However, abstract methods do not have a body. They don't have curly braces and they don't have anything inside the curly braces. An abstract method is just ended with a semicolon. That's it. It's just ended with the semicolon. There's no body to it. So if I were to fully do this, the reason why I'm making it protected, because if you want to access an abstract method, you have to make a subclass or a child class out of your abstract superclass. And that's why I like to make mine protected, because protected just means the method is visible in a child class. We went over that in modifiers. If you want to go back and look at my modifiers video, you can. So, and then you can go to my method. There you go. You're going to get an error if you put curly braces in a body around an abstract method that's defined with the abstract keyword. And that's kind of how you would declare an abstract method. This must be inside an abstract class. So I can't have just a regular class and just make it. It has to be inside an abstract class. So that compiles. However, if I just made a class A and put that method inside, that would not compile. Or if I put a body inside this method, that would not compile. You kind of get the gist. It's in the definition itself. So, once again, let's go over our words and definitions. So these 2 are defined in Java through the modifier abstract. An abstract class is just a class that is prevented or prohibited from creating objects. So you can't create an object through an abstract class. An abstract method has no body. It must be inside an abstract class. Alright, so now that we've kind of defined the 2, let's go ahead and give a little bit of an example. Hands-on demonstration. By the way, I want to write down one last thing down below. I'm trying to write a little bigger. Okay. To access an abstract class, you must make a child class that inherits the abstract class. Inherits just means it uses the keyword extends. I'm gonna put that in red for you. There you go. To access an abstract class, you must make a child class that inherits the abstract class. And I'm going to put this in red as well. It's removed from the AP test. So, yeah, just make it a little bit nicer. I appreciate those of y'all still watching. Okay, so first step, make an abstract class. An abstract class does not only have to contain abstract methods, it can contain regular methods as well. And those regular methods can have a body in them. So I can just say, I can make a protected and then I can just have a normal method inside my abstract class. It will still compile because abstract classes can contain abstract methods or they can have regular methods in them. So I can make it public void and this can have a body because it's not abstract, and then I can just print beans. That successfully compiles. But now I have to define my abstract method. And to define it, or to access it, I must make a child class out of it. All right. So the next step here is I have to access my method. So abstract methods must be overridden. A key concept to know is that abstract methods must be overridden. So it's useful, best practices, to use the @override annotation. That just tells Java that a method is being overridden. And abstract methods must be overwritten. Same when we talk about interfaces. When we talk about interfaces are just completely abstract classes. Even if it doesn't matter whether they're public, whether they're just regular methods or whether they're abstract methods, they must have a semicolon. They can't have a body. So even like this method, say beans, that doesn't have the keyword abstract, it still has to have a semicolon when it's in an interface instead of an abstract class. All right, so once again, abstract methods must be overridden. So we have to use the override keyword, and then we have to say protected void sacred. And then here we can finally have a body. And then we can just print green. By the way, this is a print and that's a print ln. I'm going to put the ln up there because this is just a print, that's a print ln. So it's just a new line. All right, so, and then if I were to make a class and then make objects out of it, which I won't really do, this is just going to print, this whole thing will print green beans. With a space because over here. Or I should say capital G and then beans. Like that. So it should print green beans. And that's kind of how an abstract class works. So let's nail it down. This is only the first part of abstraction. The second part is interfaces. So let's nail it down. Abstraction hides unnecessary details from a user. There are two sections, abstract classes and methods, and interfaces. An abstract class is a class that is completely prevented or prohibited from creating objects. An abstract class can contain either regular methods or abstract methods. Then finally, we have an abstract method, which is just a method that has no body. And it must be inside an abstract class. Abstract methods must be inside abstract classes, but regular methods can be in either abstract classes or regular classes. Okay, to access an abstract class, you must make a child class that inherits the abstract class. You can see that we made a child class B that inherits our abstract class A. And then we overrode our abstract method that was defined in our abstract class. So we nail it down, come back here, we revise it. We have our class A, and then we have our protected method, call it say green, and then we have a regular method that is beans, so we didn't have to override that in our child class because it's not abstract. And then we overrode our I cannot spell. There we go. And what we did here is we overrode our abstract method in our child class to print green beans. By the way, you can make it print beans green or green beans. This is just assuming I create an object. I call this method first, and then I call that method second. That's just a little bit about how abstract classes work. Okay, gonna do this one in a different color. We're now on to our second part, the second way to achieve abstraction, which I think is honestly the better way. I like to use an interface more often than an abstract class. So yeah, I honestly prefer it, but it's really just your choice. And sometimes it might depend. So, yeah. All right, interface. Class that is 100% completely abstract. That is what the word interface, that's just what an interface is. Interfaces must contain non-body methods. So even if the method is not abstract, and by the way, interfaces can contain regular or abstract methods, but they must all not have a body. Even though it's not abstract, it still cannot have a body in it, because you're going to define that in a subclass, or it's not really a subclass, it's more of a superclass, but it's going to implement the interface. So yeah. So interfaces must contain non-body methods, even if they are non-abstract. So even if they're non-abstract, they must not have a body. Okay, so does that cover up interfaces? All right. One more idea. So a class inherits an interface using the keyword implements. This is a very big idea to know. I'm going to highlight all the key ideas in blue. All right, so it's good. A class inherits an interface using the keyword implements. So a class inherited, a subclass inherited a superclass using the keyword extends. So now a class inherits an interface using the keyword implements. Kind of does the same task, but it uses a different keyword because it's an interface rather than just a class. Okay, how would I demonstrate this? Well, first, I'll make an interface. I'll call it A. And what I can do is like I can define a couple methods in here. I'm just going to do one. By the way, the protected keyword is not visible among classes that implement interfaces, so that's why I'm just using public. All right. Oh, whoops. I made the same mistake that I told specifically not to do. That's supposed to say implements. There we go. That's better. And then we go ahead and make another class, and then we make an object out of it, and then we print it, and that's just going to print my method. But yeah, that's how interfaces work, and they're another way to achieve abstraction. But yeah, that's pretty much it. Those are the two ways you can achieve abstraction.
Okay, so we're here on abstraction. Welcome to the coding demonstration on how we did it. We did the hands-on demonstration previously in this video. So let's go ahead and start. So we're given an FRQ, and our goal is to actually solve the FRQ and get our code accepted. You're not going to see an FRQ related to abstraction on the AP exam, but you will see it in competitive programming like types. You're not going to see it exactly like this, but you're going to see it somewhat similarly, which will involve abstraction, hopefully. So we're getting an FRQ here. Jessica is assigned to make 4 abstract methods that add, subtract, multiply, and divide 2 doubles, rounding each value. What does it say? To 2 decimal places. Okay, that's important. So I should have just zoomed out. So rounding each value to 2 decimal places. Using abstraction, assist Jessica in the given task. Okay, so abstract class 4 methods. So I already have the layout here. I commented this out previously before I actually recorded. But what this should be is that this class should give 4 abstract methods because we're using abstraction, right? And since the program already created us an abstract class, we don't need to use an interface. That's the other way to achieve abstraction. But since we already have an abstract class, we don't have to worry about making an interface. We can just go ahead and make 4 abstract methods that each do their own task. Add, subtract, multiply, and divide. And all of them should return doubles. Because we're dividing 2 doubles at a time, we're going to get a double as a result. Therefore, each of our methods should return a double. And then we have to note that we're going to round each value to 2 decimal places. A key thing to put in our main method. And we're going to achieve that by using printf. So let's go ahead and start making our abstract methods. So we got a protected double, not abstract, double. We're going to call it sum, and it's going to take in a double x and a double y. And then I can copy and paste this. I could just go ahead and put the regular methods in here instead of just putting abstract methods and then having another class override the abstract methods. Remember that whenever you're using abstraction, regardless if it's an interface or an abstract class, you have to override the method in a subclass or a class that implements the interface. Hopefully that makes sense. So whether it's a class that implements the interface or if it's a child class, you have to override the methods defined in the abstract class or an interface. So that's why we have a child class here that's going to override our abstract methods. If we had an interface, we would just have a regular class that would implement the interface and then we would override each of them. So we're going to override each of them. By the way, @override is just an annotation in Java that tells a compiler that we're overriding a method in Java. There we go. And then we're just going to copy this. Oh, but I messed up. Sorry. Product. So we overrode each of our abstract methods we defined in our abstract class. We're good to go, right? Now we have to actually tell what the method what it's going to do. The sum method is going to add 2, right? Add 2 doubles. The difference method is going to subtract the 2 doubles. The product method is going to multiply the 2 doubles. And then the quotient is going to divide them. We're good to go? There we go. We're done. By the way, keep in mind this right here. This is our input and our output samples. So usually when you do competitive programming, the AP exam FRQ doesn't show this, but like when you do competitive programming like HP Code Wars, you'll definitely see an input and an output for many of the problems. An input just means that if you input these 2 pieces of information, your output should show this. If the output doesn't show this, it's going to give you it's going to test run it, and if it doesn't show that, then your code won't be accepted because it's the wrong answer. So you got to keep in mind on that. So we're done with these 2 classes, right? This class defines our abstract methods, and this class, which is our child class that extends our parent class, which is the abstract class, will override each of the methods in the parent class. Are we done? There we go. We're ready. And now we're on to our main method. We have to decide our x and y aren't going to be constant, right? They're not going to be like, we can't just straight up define x and y, right? They're going to change every time. So the biggest thing that we have to do is we have to let the user decide what we want then, what they want to put for their numbers. So the user gets to decide an x value and a y value, right? So that's why I made 2 instance variables. Instance variables are just variables that are defined and belong to a class. These belong to a class, right? Because they're defined inside a class. So straight up, I just defined an x and a y, right? I made them private. So these are going to store what the user wants for their number. So if the user decides to put like a math.pi 3.14159265535, right? That will store as an x. And then their second number, whatever they define that, it's going to store as a y. So that's why I made 2 variables, an x and a y. And you're going to get a warning because you don't really use x and y. The squiggly yellow line just means the compiler is giving you a warning. All right. So because we're using the scanner, we have to make sure we're importing the java.util. So we have to check. We are importing java.util. So we're good to go. You'll get an error because you're going to say that the scanner is not defined, and that's just because you haven't imported the java.util package. Scanner is just a class in the java.util package, by the way. So we made a scanner called scan, and we made it read through the terminal. System.in just means it's going to read through the terminal, by the way. So I heard a lot of people ask me that. System.in just means it's going to read through the terminal. Okay? Then we're going to print a message to the terminal, right? I'm going to say type a number. After we type a number, we're going to make, oh yeah, we have to create objects, by the way, because these aren't static and these aren't static either. So we have to create 2 objects. We're definitely going to need an object for our current class, and we're definitely going to need an object for our, wait, what's the class name again? Using the for methods, okay. Okay, there you go. Don't worry about the warnings, we're going to fix those as we go. Okay? After that, we can do the try block now. And we're going to make this a.x because it belongs to the abstraction class. And we're going to make it equals scan.next double. and then we're going to catch an exception. So if it's wrong, if they don't input a double or number, we're just going to say, be sure to type a number, nothing. Okay, and then we can do this one more time, right? We have to type another number. Oh, I thought this was commented for a second. I don't know why the color coding's off on it. Oh, there it is. Just because of that. The color coding was a little off. Okay? And then we can just copy this, and this is going to store our y value. So our second number the user wants. It's going to store. Here we go. And then finally, what we can do is once the user has typed their first and second numbers, and we've stored them as variables x and y, finally what we're going to do is we're going to use a printf that will print out the sum, the product, the difference, and the quotient, rounding to 2 decimal places. So we're going to use a printf. We're going to say sum, right, because this is our sum, so we're going to use some string text. And then after that, in space, we're going to do a %.2f %n. I don't remember if I covered printf. I probably haven't. But what this means, %.2f means it's going to round to 2 decimal places. Since this is a printf method, printf is just another way to print something to the terminal, because we already have print and print line, right? Printf is just formatting, so it helps format the number. So we have a sum, and then we have %.2f. So it's going to format the number to 2 decimal places, and %n is just going to give a new line. Because in print line, it gives an extra line, right? But in printf, we don't have that extra line, right? So that's why we have to use %n to show that we're going to enter after this statement. And then after this, we're just going to go ahead and do our u.sum, and we're going to, what are we going to make this? We're going to make this a.x and a.y, right? Does that work? There we go. Okay. And then we just copy this and we do the same thing for difference, product, and quotient. I hope it makes sense why we are using u.difference, because this method belongs to our using before methods class, right? That's why we had to make a new object out of this in order to be able to access the method in this class. So that's kind of why oop becomes useful. So we made difference, and then we made a product, and then we have a quotient. We good to go? Zoom out on this code. Oh, how much should I zoom out? There we go. That's good enough. This is usually the size I code in, so I just don't really, I just zoomed it in for y'all to see better, but I think that should be good enough. Yeah, definitely that. Let's go ahead and run it now. Okay, so the terminal greets us with a type of number, right? We're going to type a number. We're going to see what the input data gives us. The input data gives us an x value of 3.2 and a y value of 4.1. And there we go. Our output value does in fact match. Therefore, our code is going to be accepted. However, there is going to be a second test case. And this is our second test case. And this is going to show, is our code fully ready to be submitted? So let's do 10, 5, 15, 5, 50, and 2. And yes, they do match. So at this point, we know that both of our test cases match, and therefore our code will be submitted if this was a competitive programming question. Since these two match, our code is going to be submitted, and we're done with this problem. And that's it. That's the end of this video. If you had any questions whatsoever in this video, be sure to please leave it in the comments below. I'm super happy to answer questions. I understand that some of it can be confusing, and I'm glad to clear up any doubts that there are present. Keep in mind that for those of you studying for the AP test, you don't have to worry about abstraction. You're not going to get an FRQ about it or an MCQ either. So you don't have to really worry about that. But if you're just interested in more coding, you want to study more abstraction, if you had any doubts, please let me know in the comments below. I'll be able to be as prompt as I can to answer the questions. And with that being said, I'll see you guys next time.